A circular loop of radius r is bent along a diameter and given a shape as shown in the figure. One of the semicircles K and M lies in the xz plane and the other one KLM in the yz plane with their centers at the origin. Current I, ampere, flowing through each of the semicircles is as shown in the figure. A particle of charge q is released from origin with velocity v vector is equal to minus v naught I cap. We have to find the instantaneous force on the particle. Assume that the space is gravity free. The B part, the question is asking if an external uniform magnetic field B vector equal to B naught J cap is applied, then determine the force F1 vector and F2 vector on the semicircles KLM and KNM due to the field and the net force F vector on the loop. So if we begin solving this problem, so the first thing that we will be calculating is the magnetic field at origin. So we begin by the calculation of magnetic field in the origin. So these two semicircular loops are there. So I again write the value of magnetic field due to an current carrying arc, which is written as magnitude of B is obtained as B is equal to mu naught Ni upon 4 pi r into alpha. Now since in this case each wire is having a single turn and they are subtending an angle of pi, so I can say that the magnitude of magnetic field due to each of them is going to be mu naught I upon 4r. So this is going to be the magnitude of magnetic field due to each of them. Now if I look at the direction parameter, so I can say that due to KLM, the direction of magnetic field is along the negative x direction. This is along the negative x direction, and due to KNM, the direction is along the positive y direction, that is along j cap. So it is simply determined by using right hand rule. So if you place your thumb in the direction of current carrying wire, then your palm will give us the direction of magnetic field, and hence we can say that in the vector form we can write a B vector as mu naught I upon 4r minus I cap plus j cap. So this is the value of magnetic field due to the two loops KLM and KNM respectively. Now the question is saying that a particle of charge q is released at the origin and is having a velocity minus v naught I cap. So if we calculate the value of force on this particle, then the value of force is given by F vector is equal to q v cross b. So we have the velocity and magnetic field both in the vector form. So we can calculate by just putting the value q. V vector is equal to minus v naught I cap cross of the value of magnetic field, which is equal to mu naught I upon 4r minus I cap plus j cap. So this is the value of the force that we obtain, and on doing the cross product we obtain a value equal to minus mu naught q v naught I upon 4r, which is directed along negative z axis direction, that is minus k cap. So we have this expression over here for the value of instantaneous force on a charged particle which is moving along the negative x-axis direction. In the next part, the question is asking if an external uniform magnetic field B naught J cap is applied, then determine the force F1 vector and F2 vector on the semicircle KLM and KNM due to the field and the net force on the loop. So for this particular problem, we can say that the magnitude of force is determined using the expression F vector is equal to I L cross B. So we can also determine the direction of force by solving this portion or by using Fleming's left hand rule. So the question is saying that the applied value of magnetic field is in the B naught J cap direction. So we have to determine the force F1 vector and F2 vector on the semicircles KLM and KNM. So in case of an irregular shaped conductor placed in the magnetic field, we use the length as the shortest distance between the two ends of the conductor. And hence, I can write that the force vector on Km can be written as Vi into 2R. And if we use the Fleming's left hand rule, we will obtain that the direction of force is along the I cap direction, which is equal to 2BIR I cap. And the value of force which is acting on the loops, that is KLM and KNM, is going to be same, and it can simply be calculated by calculating force on Km, which we have obtained as 2BIR in the I cap direction. So and hence therefore the total force acting on the loop will be sum of the forces, since both the force is same. So we just double the value to obtain the net force as 4 times of BIR in the I cap direction. So with this we solve this particular problem, which was asking us to calculate the instantaneous force acting on the particle and the force on the loop when the externally applied magnetic field is applied. So now you can have a contradiction with the previous problem where I said that the net force acting on a loop placed in a uniform magnetic field is 0, but over here the loop is carrying current in the opposite direction. So if it would be a single loop, so this would be carrying current like this, from here to here and then from here to here. But the two are carrying current in the opposite sense, and hence the forces are not cancelling each other to give us zero resultant, but they are adding up to contribute to the total value, that is we obtain 4BIR in the I cap direction.